Welcome, everyone. Today, we are stepping beyond individual productivity and exploring how to orchestrate multi-user collaboration using Claude projects. We'll learn how to unify your team's output, share vital knowledge, and establish best practices that turn Claude into an enterprise-grade collaborative engine. Let's get started. Let's begin by defining team AI integration. Moving from a single-user setup to a multi-user environment means transitioning Claude from a personal assistant into a shared, organizational brain. The basics involve establishing shared access management, defining who has permissions to alter core project instructions, and setting up activity monitoring. Why do we need this? Because if your team uses AI without coordination, you end up with chaotic results. One person's code or marketing copy won't match another's. We solve this by defining a shared Claude project workspace. In our deep dive, we realize this requires a fundamental mindset shift. You are no longer just prompting for yourself. You are architecting a shared environment. We must ensure that when any team member interacts with the project, the underlying context forces Claude to output work that aligns perfectly with your company's specific, unified standards. Take a look at this flowchart contrasting two organizational approaches. On the top path, an uncoordinated team uses AI in silos, inevitably leading to inconsistent outputs and wasted, duplicated effort. Now look at the bottom path. A collaborative team funnels their workflows through a shared Claude project. This acts as a unified knowledge base, which acts as a filter to ensure that no matter who is submitting the prompt, the result is a consistent, high-quality output that perfectly matches corporate standards. To make a shared workspace effective, we must master structuring shared knowledge. A Claude project acts as a smart folder where you upload your background materials like API schemas or brand guidelines. The most powerful tool here is the Claude.md file. This file provides persistent project memory containing shared rules and conventions, and it should be committed to your team's version control. Why is this critical? Without it, every developer or marketer on your team wastes time and tokens constantly re-explaining the company's rules to the AI. By centralizing this, Claude knows the rules before your team even types a word. For our deep dive, understand that Claude respects a memory hierarchy. While your team shares a project-level Claude.md, your IT department can actually deploy a managed policy organization-wide that supersedes project rules, ensuring absolute security and compliance across all teams. This architecture diagram illustrates the memory hierarchy that powers shared context. At the top, the organization level can enforce a managed policy Claude.md that cascades down. Below that, your specific team level contributes the project Claude.md alongside any uploaded assets like schemas. All of these feed directly into the Claude context engine. As a result, when user A, B, and C initiate their individual chats at the bottom, they all inherit the exact same structural guidelines and business logic. Sharing context is only half the battle. We also need consistent prompting strategies. This means establishing a centralized template library for your team. The basics involve replacing ad hoc, messy prompts with pre-approved templates utilizing blank variables. Why do this? Because if a junior team member and a senior team member both asked Claude for a code review, you want the exact same level of rigor applied regardless of who asked. How do we implement this? You establish a shared playbook outlining your specific style guidelines and quality standards for AI-generated content. Look at the sample prompt on the slide. It uses a variable bracket and explicitly points Claude back to the shared project knowledge. In our deep dive, we recognize that standardizing prompts transforms the AI from an unpredictable chat interface into a highly deterministic, repeatable business process that scales flawlessly. Notice the workflow established in this diagram. Everything originates from the team prompt library. A user selects a standardized template and simply inserts their specific variables. This payload is handed to the Claude project engine, which applies the shared knowledge base. Because the input was standardized, the outputs, whether a code review or a marketing brief, are completely uniform, eliminating the variance that usually plagues multi-user AI systems. In a team environment, work rarely stays with one person. We must establish handoff protocols and artifact sharing. The what is the procedure for transferring AI-assisted context between colleagues. Here is a critical basic fact you must remember. While projects organize your files, they do not automatically maintain context between different conversations. Why does this matter? If Alice finishes the data analysis phase in her chat, Bob cannot simply open a new chat and ask Claude to continue where Alice left off. Claude won't know what happened. How do we solve this? We establish a strict handoff protocol. Alice must prompt Claude to generate a comprehensive continuation summary and save it as an artifact in the project. Our deep dive reveals that this summary must include the task overview, the current state, and the next steps. Bob then opens his fresh chat and explicitly points Claude to Alice's summary to resume the work. This state diagram perfectly maps the handoff lifecycle. User A is working in their session. When the task is paused, they trigger a state change to generate a continuation summary, which is immediately saved as an artifact into the project knowledge base. When the handoff is initiated, User B opens a brand new session, but the very first action is to load the summary context. This bridges the gap, allowing User B to flawlessly execute the next steps. To truly harmonize a team, we implement and enforce team output styles. The what is configuring your project so Claude always responds in a specific format. The basics involve moving away from standard prose and forcing Claude to output markdown tables, YAML, or structured code blocks. Why? Because if 5 team members are generating components for a larger report, those components must visually and structurally match to be integrated. How do we enforce this? You can define a custom output style file inside the projects.claude/outputstyles/directory. For our deep dive, understand that an output style isn't just formatting, it modifies Claude's underlying system prompt. It overrides Claude's natural tendency to be chatty, replacing it with a rigorous structural protocol. Your team's output becomes highly predictable and professional. Follow the sequence diagram to see output enforcement in action. Both User A and User B submit distinct analytical queries to the Claude project. Crucially, before Claude responds to either, the request routes through the output style engine, which applies the team YAML standard. Consequently, both users receive perfectly structured YAML responses that are identical in format. User A and User B can now seamlessly merge their data. Even with perfect prompts and styles, we must establish quality standards and validation. What does this mean? It means defining strict acceptance criteria for anything the AI produces. The basics require a human in the loop. Why is this critical? Because working in a highly optimized shared project can create a false sense of security. The team must remain vigilant against factual errors, logical inconsistencies, and tone mismatches. How do we systematize this? You add a review checklist document to the project knowledge base. Every time a team member generates a major deliverable, they must physically verify it against this checklist. Our deep dive strategy is to use Claude to check Claude. Have a second team member take the output and run an evaluation prompt against it, ensuring peer review is baked into your AI workflow. This flowchart maps the essential quality standard validation path. Any AI-generated output immediately hits the human review gate. It splits into 3 mandatory checks: factual accuracy via cross-referencing, tone validation against brand guidelines, and logic verification via an evaluation prompt. All 3 paths converge at the final decision node. If it fails, it routes back for refinement. Only when it passes all checks does it reach the green node, approved for team use. Let's look at a highly practical, real-time use case: cross-functional software launch alignment. Imagine a company launching a major new feature. Typically, development, QA, and marketing operate in silos, leading to messy, misaligned messaging. Here is the execution. The team creates a single Q3 release Claude project. They upload the master technical spec, the company brand guidelines, and the target audience profiles as project knowledge. The workflow is transformative. Development uses the project to generate technical documentation. QA enters the exact same project and prompts Claude to generate test cases based on that documentation. Finally, marketing uses the same project to draft the public release notes. The outcome: all 3 departments produce content that shares the exact same terminology, scope, and factual foundation because they are constrained by the same shared memory. This completely eliminates the miscommunications that normally delay a launch. This mind map illustrates the hub-and-spoke model of our use case. At the center is the shared Claude project. Branching out, we see development generating API docs based on the specs. Quality assurance reads those exact docs to generate their test cases. Meanwhile, marketing leverages the specs to draft the release notes. By keeping the core knowledge centralized, every branch naturally aligns, resulting in our ultimate value: total cross-functional alignment. As we conclude, we must discuss governance and scaling. The what is protecting the integrity of your shared project as your team grows. The basics require implementing strict access controls, such as deciding how to allocate usage across team members and establishing proper account structures. Why is governance necessary? Because without it, shared project files become bloated, prompt libraries degrade into chaos, and your token costs will spiral out of control. How do you prevent this? You must designate a project owner whose sole responsibility is auditing the project, pruning outdated context, tracking usage, and ensuring the master Claude.md is strictly maintained. A multi-user Claude project is a shared digital ecosystem. Treat it with respect, and it will elevate your entire organization. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for watching. Our final diagram charts the path to sustainability. As team growth occurs, you must immediately establish governance. This branches into monitoring usage and designating a project owner. The project owner takes active steps to prune outdated context and update master templates. Adhering to this rigorous maintenance cycle is the only way to achieve the final green node, a highly functional, sustainable AI ecosystem for your team.